Let's say you're working on an old radio and you're checking all the resistors, you've recapped it. You come across one of these and it measures open. So you go ahead and replace it with the correct value. Even though these values look a little strange, you just change it out. And then the radio never works again. Well, we have here are, and they look exactly like carbon resistors. 1966 RCA CTC16 color roundy. This will be part one, an analysis. The owner wants to fix this set up, so that's what we're going to do. We're just going to analyze it, check it all out, get a good assessment of it in this video. Don't trip because the legs aren't on it. The legs and the knobs are right here. They were just removed for transport. This is a fairly popular set. One of the more desirable ones of this type. And it looks like we have a small cataract here. This is removable. This is serviceable. We will do that at some point. I wish it was further in, because the further in it is, the easier it is to remove and clean it out. But this one's just sort of on the edge, so we're going to have to work at that a little bit. Looks like something was gnawing on the corners here. The particle board. $375 watts for today's carbon neutral service needs. Let's get it open and inspect. Wow, so this is a remote control set. That's the remote receiver module right here. That makes it sort of desirable. So start looking for a remote control for this thing if you care about that. I personally don't, because you just put them on channel 3 now with the converter box or DVD player. So what are the weak points of this set? Well, the CRT, but those cups look good. Not that that means anything. But there is very little discoloration there. What are the weak points on this set? Well, the flyback, for one thing. The flyback is far more of a weak point than the electrolytic capacitors. Traces on the circuit board, tube sockets, the circuit board itself, carbon tracking. This thermistor likes to fall apart, which it just did. I just touched it and there it went. The degaussing thermistor, so I just barely touched that, so that's done. So we'll have to replace that. It is a CTC16X. This is a good one. Yeah, this thing was something like to chew on this thing. What are the other weak points? I don't know. These are pretty good. Like I said, the circuit boards, especially in this area right here around these 6G7s, because of all the heat the circuit boards cook. Let's look at the flyback. This is got some hours on it. It's lost quite a bit of wax. Yeah, actually quite a bit. I'm not even that stressed about these because we can rewind these now. We know the formula to rewinding the secondary. The donut is what fails, the high voltage. This part right here. The secondary is below my finger where these are. This is the secondary. I'm sorry. This is the primary in here. The primary. This is the secondary, this big part right here, and this is what fails. Can rewind those with modern, a lot of patience and modern supplies. Let's check the tube. CRT is an RCA highlight. It's a replacement. This high voltage rectifier, this 3A3, also has a pretty high failure rate. These go to air just like the 1B3s. Nothing. Really? I'm at 6.3 volts. Let me come up a little bit. God, is that dead? What I'm blanking out on is, I think there was an RCA Colorama and there was an RCA highlight. Maybe the Colorama was rebuilt and the highlight was all new. I forget. This is setting the cutoff. It is starting to wake up, but I'm going to give it a minute just to let it run, but it should still, if it's a strong tube, it should. When you give it a minute, you don't leave it on test. Leave it on setup. That way you're not just driving endless current through the cathode. I mean, by looking at this, you would not think that I mean, that certainly does not look all blue and does not look high hour. The whole set does not look super high hour. Okay, 10 minutes later. The patient is still dead. Let's get a different doctor and get a second opinion. Let's see what the miracle in a briefcase has to say here. Poor. I guess we just gotta resurrect it and see how it looks. Where are these set? Not all the way up. Not all the way up. Not all the way up. About equal. Okay, where's the bias? And the bias is all the way up. So as the tube gets weaker, you turn the bias up. That's the way you're supposed to do it. You should always have one screen at maximum and the bias at the lowest possible setting to get the line. So this does almost look like this tube is had it, and that it was had it when they put the set in storage. Let's power it up. We'll put a meter on the horizontal output and power it up and take a look at the cathode current, see if it produces high voltage. And no, I'm not going to rejuvenate or clean and balance or any of that. That's a temporary band-aid fix to shut the customer up until the new CRT can come on the next truck, or the customer can buy a new set. I've done that, and it actually makes it worse. It'll make it brighter temporarily, but then after a couple days, it's actually far worse than before you screwed with it. So I'm not going to do that. So we got to bypass this thing. And that just defeats the degaussing. I got to bypass that. Power's turned on the front of the set. I'm using a 300 milliamp meter. We should really see about 160 milliamps on the plate. And I'm going to just current limit with a 500 watt bulb here and just go for it. Hope I have the meter hooked up right. We'll find out. If it starts to go backwards. It's going backwards. Let me reverse these leads. This meter is accurate. Those are 1% resistors that are on there. I got it calibrated. You're supposed to really measure the cathode current because there's super high voltage pulses there that will cook you. But we don't really take precautions here, so. This is something that I don't see anyone else check, and I always check the amount of current flowing, amount of power flowing through that tube is how well your horizontal circuit is tuned and everything's working. I'm going to get a high voltage probe. Okay, we're at 15K. I'll bypass the light bulb. We're looking okay here. $120. 140 seems a little low, but low is good. Liquefied. Liquid VDR. Now, why would that do that unless it was shorted? And that would make sense why those lines were going through the picture. How you saw those strobing lines. Unless that would have to be shorted. Because with this, the resistance goes down to nothing when it's hot. So that VDR had to be shorted. Which means the degaussing coil is slightly warm. But ooh, Meltomatic. Wow, is that hot? Holy crap. I mean, we are still smoking hot here. Thing actually desoldered itself. It had to be shorted. But yeah, I bet we don't have those lines running through the raster now. Yeah, see the difference? We actually have snow now. We don't have those lines. I don't quite understand this, because what this does, when the voltage drop is high across this, when the voltage drop is high, this starts to conduct. As this warms up and the resistance goes down and the voltage drop across it drops, this acts sort of like a relay. When the voltage drop across this gets below a certain value, this stops conducting altogether like a relay. This completely removes the degaussing from circuit. It's a VDR. I wonder if we could find a modern replacement for this on DigiKey. I have these. They come as a kit. And I know this is basically a CL90, but I don't know what MOV this is. Could probably solder the things back onto it. We've come up, we're right at 160 here, so that's good. We're looking good here. That and the VDR, like I said, those come as a kit. You always change those together. Actually, I need to retract to something I said in air. The bias is all the way down. Up is all the way down. Makes perfect sense, doesn't it? Well, that's good and blurry, and the purity is completely cut it out. The purity's trashed because of how the degaussing went down, how it just got cut off. But the color demodulation's working. It's very blurry. This is what happens when you're working outside during the day. Anyway, that's either the convergence is completely whacked or something else. So, okay, I think we got a pretty good analysis here. We move forward. The CRT is not great, but I think it's going to do okay. It might wake up. It's definitely not virgin or fresh, but it's got some hours on it. But I think it'll be okay. It'll produce an okay picture. They're all cool. They use good electrolytics in these things. They really held up well. So horizontal output looks good. CRT is okay, just okay. We need the VDRs, we need to do the cataract, complete setup. All this is not right. This should be straight up and down like that. This should be over this gun right here. See if that affected anything here. It did. It brought it in a little bit. I think we got a winner here. So we know what we need to start working on. Cataract, VDR, and I might try and come up with a modern replacement for that VDR, like the CL90. You can go on DigiKey or Mauser and buy a CL90 inrush current limiter. It's exactly the same specs as this thing. But the VDR, we need to figure that out. Now there's another VDR that's used in the Zenith high voltage, and Mr. Harland figured out a suitable replacement for that VDR. It's just, I believe it's the same as a metal oxide varistor. One of those things that's in a power strip that when there's a surge blows up and sets your house on fire. It's basically the same thing. At a certain voltage it starts conducting. And in a power strip, it's supposed to start conducting, I don't know, at 180 volts and blow the circuit breaker. Well, they usually don't do that. They usually start conducting, and when they get hit by lightning or something and just end up blowing up and spraying burning crap all over the place and melting the power strip. So anyway, 1965, 1966 CTC16 by RCA. Part 1, the analysis. Part 2 will be either the cataract or something else. Okay, don't try this at home, kids, period. I think we should be able to get the value of this VDR by doing this, just testing it like a Zener diode. 25 watt bulb, when I short these together, the bulb comes on. I'm measuring the AC voltage drop across here. So if I put the VDR in here, like that, the bulb will come on. So the VDR is about 24 volts. And I think what was happening here is I don't think there was anything wrong with this. I had a bad connection. Probably had a bad connection where I touched those wires together on the thermistor. So this looks like that says 23.55. So it looks like it's about a 25 volt VDR. Okay, let's do some testing. Here are a bunch of these VDRs. These are the thermistors here. These are the VDRs. I'm going to just start testing them, comparing them. This one's measuring 27 volts. Next is measuring 23 volts. Here's a brand new one. This one's measuring 25 volts. Next is 23 volts. Next is 25 volts. Here's a green, more modern green one. It's measuring about 24 volts. Oh, 20 volts. Interesting. So is that what we're looking for? About a 20 volt? There's another one, 24 volts. There's another one, 27 volts. Well, I'm going to guess, since the 20 volt one measures about 24 volts, and all of these black ones measure about 24 volts, and this is 20%, I'm going to say we want around a 20 volt VDR. So on DigiKey, I'm going to do around 20 volts here. We'll do that, and then we'll select through hole, and it looks like 22 volt is a real common value. This, I'm liking this. 20 millimeters, TDK, $1.64. There's another one. $1.17. 20 millimeter. So I went back here and selected 20 volt, and there basically are none. There's only surface mount. So 20 volt is a no-go. Let's see about... Still nothing. Still nothing. Let me look at this. So you don't get any options until you go to a 22 volt. I wonder if we go lower. I wonder if we go to like 18. We'll do these. Yeah, you do. So it looks like if you want the 20 millimeter, the heavy duty one, it looks like you have a option of either 18 volt or 22 volt. That's it. So the way this works is when this thermistor is cold, and this is the one that I touched and it fell out, the resistance is high. This is maybe 120 ohms cold and maybe 5 ohms hot. So when this is cold, there's a large voltage drop across it. So this starts conducting. This is the VDR that I'm looking for right now. So when this is cold, the resistance is high, so the electricity flows through the degaussing coil through the VDR. As this warms up, the resistance drop, the voltage drop decreases. This stops conducting probably around 15 volts or so, and basically takes this out of circuit like a relay. It actually tapers this off. So this is just a CL90. This is a CL90 right here. This is a house. This is somebody's estate. Furnace, not for sale. Holy crap. Wow. Look at all these old capacitors. Guess that's off limits. Christmas tree in July. It's all wood. It's all like reclaimed wood. See the nail holes? The whole house is built out of like reclaimed wood. Not work. This house is a trip. The floors are plywood. All the walls are wood. Oh, wow, we have drywall. We have a drywall ceiling. Oh, wow. Holy crap. These are those little personal radios. The little Japanese personal radios that have the 1R5, 1U4. How many of these do you need? Sanyo. Mayor. Old school clothespins. Wow, look at those. Again, this is a bedroom. Look at plywood floor. Oh, look at wheels for tuning capacitors, ball bearings. Wafer switches. Again, floor is plywood. This is wallboard, right? Yeah, that's wallboard. Unfinished. No need for moldings. No need for moldings. This is one of those navigator with the tubes. It's got the rotating antenna on top of it. Another one. These are the navigator radios, but they're just like an AM radio with tube. Again, more navigator. These are all navigators. You rotate this antenna. I think they use these on boats before GPS. Yeah, you rotate that and it'll tell you where KNX is, so you know where to crash the boat into the pier, or where KNX is coming from. These are all navigator radios here. That you'd... the Christmas tree. I want the Christmas tree.
Of course you do. It's your style.
What was this dude's deal with? Did he build this house himself or what?
It's a collector.
No, but I mean the house with the plywood floors and...
I think he got it by his contractor.
Wow, look at this.
Never finished the house. Like 20 or 30 years ago.
Look at the antenna on this thing. You know what I'm really kind of, I mean, there's too much here. It's overload, right? But
Yeah.
what sort of stands out to me first are all those things upstairs, all those bins with the parts in them.
Yeah.
I mean, since I mostly do component level stuff anyway, that stuff is real appealing.
No, you can make an offer. I mean, anyone that's coming through is, paying fair stuff for stuff.
Unfortunately, I'm not. The truck is still full of transformers, and yeah, this is what I'm interested in.
Okay.
Sort of. Oh, all the tubes.
Too, with those, everything I guess.
Oh, all the transformers and all that.
Yeah. I see. I have coils galore. Coil forms, wire, knobs. That is all chassis boxes, mostly unused. The blue bins and components, $25 a go.
Who has display cases in their house?
Kind of set up like a little shop, like a store. Yeah, kids or no wife, so he can do whatever he wants with his house. Make good money. He's an engineer. He was a pilot in the Air Force prior, so.
Yeah, I mean, I don't think I can refuse some of this stuff. Especially for doing silver mica disease and all of that. But I just got to go through and pick out what I want. It's like so overkill. This guy had a total air capacitor thing going on here. I mean, house is a trip, man. Look at this. They're these old, crappy Japanese capacitors that short out. What's really incredible about this is how the guy had absolutely everything labeled. Everything is labeled. The value is on every capacitor. Records, $1 each. Ooh, the Dukes of Dixieland. Ooh, that might have to come home with me. We have a Christmas thing. Ooh, stereo. We have a real Christmas thing going here for a single guy. I don't know. Wow. Code records. Learn code. 6 words a minute. Wow. U.S. Navy. I might have to grab a couple of these just so we can hear them. Yeah, I wanted to come back and look at the tubes. Look at every tube is labeled perfectly. I bet they're all tested too. These are all your old batteries on display, of course. We are rolling in 60 frames a second right now with the unfinished house and the... What do we have here? Magnetic shield. What the number is on this. 3RP1, Robert Paul 1. So I think that's like green. A lot of these 1 volt tube, 1 volt radio tube, 6AQ5. That's a TV audio output. AT8. Some of these are TV/radio tubes. Here we go, 1U4. Wow, you got enough 1U4s here. 1U5. I have to grab a few 1U4s. 3Q5, that's a audio output tube radio. These are mostly radios. 6BA6, 6BE6, 12AV. These are all your 5-tube radio tubes. 6AU4, that's a black and white horizontal output. These are... It's like overkill. We got wood. The whole house is kind of cool. It's like a garage. I dig it. And it has a very wood smell. Integrated circuits, all separated out. What do we have here? Porcelain standoff stuff. Yeah, I mean, it's like... These are all your radio power transformers that are always going bad, you know, that I'm always fighting with. Ooh, some lead jacketed rectifiers. Every one is meticulously labeled. "70-volt line transformer." That looks good right there. Oh yeah. Huh. I sort of like that box. Every screw you could imagine. Rubber gizmos. Is this like OCD or ADHD or what acronym do we assign this condition here that we're looking at? Wow, look at that level. More hardware. And more hardware. And more hardware. And radial arm saw. This is all your wood screws, standoffs, more wood screws, nails. 16D box nails. Wonder if this is the old school antifreeze that doesn't have the stuff in it that dogs don't like. Bug and tar remover. What the hell is this thing? Is it a brake for doing sheet metal work? God, this guy could build radios from scratch here.
You got 200 or 225?
Did you get the stuff in the car?
Yeah, 225.
Okay. How about these brushes?
We can have them.
So if you look at this beam, it's bent, warped down towards the end. See that? See the curve in it? And then these can't be 1x6s. They gotta be, because they couldn't span that far unless there's another roof on top of this, right?
A little bend is okay.
No, but I mean the span of these without support.
Yeah, I don't know. I mean, there's a roof above, but there's supposed to be a couple hundred of them up on this.
It's just here because it likes the 2-cycle engine noise.
Yeah.